Hey, everybody. Fascinating guest and topic today. We're talking battery powered AI and what that means with Ambient Scientific, innovator in this space. GP, how are you?
I'm doing good, Ivan. Thank you very much for inviting me here.
Well, thanks for being here. Fascinating time and topic. Maybe give us some insight into the mission at Ambient Scientific and the inspiration for the company.
Okay, I'll start with the inspiration. Actually, my inspiration has been mostly personal to start the company. I used to work for a chip company that was developing chip for competing with the mighty NVIDIA. NVIDIA was not mighty at that time. I'm talking 2010, 2012 timeframe. AI had just started on the horizon, and we were going to build an AI chip. In 2016, I had a personal accident where one of my dearest fell and could not survive the incident. So that was a very tragic incident. I have been a chip designer right from my college days. So working in AI, it told me, or I thought, this is a problem I can solve. Making intelligent sensors that can detect um, incidents like fall or even other more severe incidents. So that was the starting of this company, the inspiration. So I thought about building AI computing or deep learning computing or more intelligent computing based on deep learning that can actually get into very small device like a locket or like a ring or um, so from there our journey started. The inspiration, as I said, was tragic but personal. um, I exited that company that I was working for, and then we set up a team. I funded the operation and we started a technology um, of building very, very low power AI computing. Now, this over the time, it has proven to be far more difficult than the inspiration. However, luckily, we have been able to solve the technological barrier, and now we have such devices, and I can actually show a few of these devices when you're ready.
That would be fantastic. And, just personally speaking, I have an Apple Watch, I have an Aura Ring, I have Meta glasses that have AI. So clearly you're onto something big in terms of, ambient computing, hence the name, I guess. What are the kind of use cases, in healthcare and elsewhere that you see driving this opportunity? Is it mainly wearables and healthcare, or there's a whole array of devices that need low power, ultra low power AI?
So, Ivan, this is a good question. Let me actually show you a couple of devices that our customers are building. That will actually give you a good idea of where this can go and
Brilliant.
what of. This is a locket that I talked about, which was the starting point of my journey for this company. This should be available in the market very soon. This can detect an asthma attack. It can detect a fall event. It
Wow.
can also detect somebody being assaulted. The battery goes. It's a very small battery that goes in this part of the device, and this can run for months on such a small battery.
Months. Wow. That's
Yeah.
pretty impressive.
Important part is this is targeted to cost $15 or less in retail price.
Wow.
So yes, I mean, a lot of expensive devices can do some of the activities we are targeting. We are bringing it to a common people's use. That's why Ambient Scientific, science that can be around us.
That's a wonderful mission. And maybe talk about the silicon you've built and are building, and the tech stack in general. Like, how do you get a $15 product to market like that?
Yes.
No small task.
I'll just give me a time to show you another device being built by a customer. This is a camera. This is at the back, and the customer has built the rest of it. This will become a cam device that can detect guns, it can detect faces, and
Wow.
sale price for this is also 20-25 bucks. This is retail price. What it
Amazing.
means is you can install a few of these around the school and protect the entire school in 1,000 bucks or less. And if one of this goes bad, this just has a battery on the back, and you can put it on any pillar, on any wall, just nail it. If you lose one of them, no problem, go buy another one and put it. So these devices can be life-saving devices, can be very critical for our everyday use. The technology we built, Ivan, is called it's called the in-memory analog computing. If you open, if you go type analog AI or analog computing for AI, you will find lots of text. Most of the text will talk about that, if you can make it happen, this technology can give you very low power, can be very high performance. But all of those papers also tell that this is very difficult to make it happen. This includes some very renowned scientists, computer scientists in the world, including some from NVIDIA. So we hopped on this journey knowing that this was a very difficult technology. As I said, aspiration was good, but the journey wasn't. Um, we modified this technology slightly to make a more hybrid analog digital technology. We call it DGAN, but it's basically a hybrid of digital and analog, which is able to achieve able to give you 80% of the benefit, but doesn't have the problems of the analog technology that most people talk about. So by mixing the two benefits of both digital and analog, we have been able to solve the problem, 80% of it. And now we have the device. So to make it affordable, we built it in 40 nanometer. Let me show you a device. I'm sorry, I just lost down that fell. Give me just a second to find it for you. So the chip is a very small chip. It is built in what you call 40 nanometer device. If I can show you. That's how small it is. The die is just 3 millimeter by 3 millimeter, built in the very, very old technology in 40 nanometer. What it means is very affordable. This is the chip that goes on this is what we call package, which is mostly plastic and metal on top. That's it. So this is all fully ready. Because we built it in 40 nanometer, it is very affordable. Now, the challenge was that if you build it in old technology, how do you achieve the performance and power consumption? Because older technology generally means lower performance and more power consumption. This is where this technology called hybrid digital analog technology called analog AI computing comes into picture. This is able to solve the problem. So by cracking a very hard technology, we are able to make it affordable and still provide the performance and the low power required to make it for a common person.
Fantastic. And what a great way to reach, the billions who might be left out of the Apple Watches and the smart glasses that cost, $1,000 per unit. But what kind of software stack, what kind of embedded software, AI software can you run on these style of devices, and how does that work for the OEMs?
This is very good question. And as you know, for the chip designers, the designing a chip is one set of problem, and then you need to develop the software stack on top of that, which is generally not the fun part for chip designers, but we have to do it. So we built a complete, let me give you a little bit background. So in our case, we built our own instruction set. And if you would know, in past 30 years, I think, in past 30 years, no new instruction set have been designed. All new instructions are being designed in past 5-6 years by startups. Um, the last instruction set was designed was the GPU that has become popular. There have been many that have been designed in PhD projects, but they have not become popular yet. Risk 5 will be another example. So that was with the latest. So we designed our own instruction set that actually makes it very efficient to do deep learning computing. So we have to, whenever you design a new instruction set, you have to design your own compiler. So we developed a compiler. Then we developed all kind of embedded tool chain, which are called device drivers or firmware that connect us to either RTOS or embedded Linux. In future, we have the plan to make it Android or iOS and the full-fledged Linux connector as well. The application developers have to develop in Python using TensorFlow or PyTorch or one of the popular frameworks, either from Google or from Facebook or from Microsoft or from any of these companies. And we connect that to a popular middleware that is called ONNX. From there onwards, we have built our tool chain that uses LLVM and our own custom data path structure to bring it to our chip. The good news for the developers is that they don't have to learn anything about our chip. They will design it in Python and use the TensorFlow and PyTorch based libraries to basically build the application for our chip. We also did design integrated tool chain that is able to help customers do the training. What that means is that using our tool chain, the customers have to bring their data, have to put in their algorithm, and then after that, all of the tool chain we have been able to provide based on TensorFlow.
Fantastic.
Yeah.
So I imagine your device, is it sampling now? Can OEMs, developers get their hands on the toolkit and samples? I imagine not just in healthcare, but in all kinds of industries, you can embed your product at price points and power requirements that are unheard of, whether it's, maybe children's toys or bicycles or clothing. What are some of the opportunities that you see, not just in healthcare, which sounds like a fascinating opportunity, but in other industries? I don't know, agriculture, wearables, fashion, these kind of things.
So the important part is that you see the use of sensors have been increasing in our life. I mean, nowadays we wear at least tens of sensors around us, whether in form of a watch or if you're carrying a cell phone alone is carrying more than 20-30 sensors with you. So we wear dozens of sensors with us nowadays wherever we go. Making these sensors intelligent will create these applications, whether there is in healthcare, as you said, whether that's an intelligent toy, or it is an intelligent audio device, or it is an intelligent camera, or it is intelligent sensor that is monitoring health of my refrigerator, health of my motor in the industrial environment, or is filtering out a noise that I don't want to hear. I want to, let's say, talk on airport or in a very noisy, but only my voice should be recognized. All these applications become very feasible. So our first chip has ability to take up to 20 sensors simultaneously and mix the data to build AI applications. Right now, we have applications in all of the areas you mentioned and some more. So let me give some examples. If there is a company that is building industrial predictive maintenance. What they do is they put in the sensor on the motors that are running, and they build a digital twin. Think about metaverse for machines. And they're monitoring the health of these devices. What this does is this allows the factory to run smoothly, and you're not always dealing with disasters. Idea is to avoid the disasters altogether. So they already have, I mean, our first customer already has such a device installed, except they are having to wire these sensors to a server. But wiring these sensors in industrial environment is very expensive and very cumbersome, because they have to dig the floor to lay the wires, and that in a factory environment is not very easy to do. So they need to make it wireless. However, when they make it wireless, they start transmitting the sensor data to the server, then the battery runs out of gas immediately. So for those, they need to be able to do a lot of processing on the device itself. That's where our chip comes into picture. So they are using our chip to build a very small sensor where the batteries will run for months, and they don't have to dig the entire floor to lay out any cables. So this is an industrial, very good example of an industrial application. There's a company that is using our chip to build a sports performance analysis. So they are doing it for soccer. You can imagine this going into golf club and baseball clubs, and in cricket bats, and all kind of. I mean, even a swimming watches that can analyze if somebody is taking the right strokes or needs an improvement. So these type of intelligent sports gadgets, we should see them getting better and better over time. There is a company that is building a heart monitor device that can actually predict some of the common conditions, and basically keep the doctors more brave. This is for patients that are admitted in hospitals, or even for have some kind of heart conditions at home. You imagine this going to the sugar monitoring devices and other type of healthcare. The locket I am talking about, this will also be able to detect an asthma attack. I intend to give it to my mother soon, so that whenever she starts getting such an attack, I get a text, I can tell my family members or some attendant to go and take care of her. Because as you know, in modern days, we are all living very far away from our parents. That's we need virtual eyes to be able to monitor them, or to see them, or to be near them. We are bringing that virtual presence to them.
Wonderful. And I imagine, given the low power and form factor, sustainability is a really important driver for your solution. We all know AI requires lots of power, very power hungry. What are the opportunities to make more sustainable homes or buildings with your technology, climate control and smart sensors, energy saving solutions? That must be another opportunity on your radar.
Yes. So smart homes, especially for elderly care, a lot of customers have started inquiring. Actually, we have many of them waiting for this locket device to be available. Somebody wants to monitor the presence of your father, where he is at home. Is he walking? Is he running? Is he fallen? Is he sleeping? If he's sleeping, how is his heart doing? How is his sleep doing? All of these things people want to. So smart home, especially for elderly, is a huge application. We do have a lot of inquiries coming in for security, especially for schools. There's also a company, very interesting. They're building this very smart speaker, Evan, which is just as the speaker is playing music for you. But if somebody walks in to your shop with a gun, you can shout some secret phrase like, "Ivan, where are you?" And that would go and trigger a notification to the authorities or to somebody you trust.
Well, it's so incredible. Well, I imagine you have a lot of partnerships as well. I see some of them here on your website. What is your go-to-market like? Is it through partnerships? Do you participate in different standards organizations and bodies? I'm thinking like TinyML and other initiatives that probably are quite simpatico.
So our R&D one took very long time to materialize, because, as I said, it's a very difficult technology. Our chip has been available only for a few months. Wow. We are now started building these partnerships. we have so far gotten all our customers where customers looked for us. So now we are going to build the partnerships and especially distributors, representative systems, solutioning companies. Actually, I was talking to one just this morning, wherein we can be in the background, and these houses or these businesses can go and solve the problems for customers. So we are partnering with solutioning companies, with distribution companies, with the services companies, with the manufacturing companies, and that will happen over next few quarters.
Can't wait to
Yeah.
see it unfold. And of course, 3 months away, CES,
Yes.
probably the biggest event for you and this whole industry.
Yes.
I'll be there. I know I'm just making my travel now. What can we expect from you there? I guess you'll have a lot to talk about at that time.
We should see some of these devices in action, actually, and we will be there to sign up customers who would be interested, the distributors, the solution creating companies, the software companies, the manufacturing companies who can be attached to us. So yeah, we are very excited. CES has been a great event for us, actually. I mean, incredible. And this time we are expecting a lot of good results.
I'll be sure to see you there, and congratulations on all this success. Such an important and interesting mission, and onwards and upwards. Thanks so much, GP. Thanks for your time and sharing the
do
vision.
want to mention one thing before we. So
Sure.
this technology is created in such a way, Ivan, that we can replicate the number of cores to as many times as we want. So you will see us emerging as a company, not just providing this one chip for doing the sensor intelligent, but then for very high speed vision, for automotive, for autonomous driving, moving forward to building very intelligent laptops that you can play good video games with, can make connections, can start all these kind of calls, can do security monitoring, coming.
Wow.
Very soon you will see a lot of these distributed, right now AI training, Ivan, is happening into these big machines that is all very just one machine doing everything. As it happened in the normal compute industry, all led by search, by Google in the beginning, where the very massive computing got broken into small pieces in a distributed computing. Same thing you see emerging in AI world as well, wherein every small machine can participate in the training mechanism. So you should expect us to play an important role in that journey over next few years.
That's fantastic. Well, it looks like you're not just trying to conquer the IoT space, but the whole computing world. Maybe you'll be the next ARM or the like. So congratulations on that. And it's great having big goals. That's always
hopefully next NVIDIA.
or the next NVIDIA.
Yeah.
Fantastic. Well, thanks so much for joining. Really intriguing work, and can't wait to try out one of your devices one day for me or a family member that needs it. Thanks so much, GP.
Thank you very much. Take care.
And thanks everyone for listening and watching. See you at CES.
Yeah. Thank you, everyone.